So Ken, Dominic?
Yeah, hello everyone.
Okay, good. It's good that you are on the positions. So hi everyone. I'm Mihaela. I'm the marketing director of Sardina Systems, and today I'll be your host for this webinar. First of all, I would like to thank you very much for your time, for taking your time to be with us today. I'm very happy to see that our topic about building a large-scale infrastructure as a service with OpenStack and software-defined storage raised your interest. Some technical details. The webinar will last approximately 50 minutes, and we'll have a question and answer session at the end of the webinar. I encourage you to send us all your questions here on the chat window, and stay with us until the end of the webinar when we will answer to all your questions. I would like to introduce our two speakers today. We have Kenneth Tan, Dr. Kenneth Tan, who is our technical director at Sardina Systems, and he will speak about the OpenStack technology, how to build a reliable and scalable infrastructure as a service with OpenStack, and what are the challenges for it. And on the storage side, we have Dominic San, who is the sales marketing director at Ambedded Technology, and who will speak about Ceph storage and the software-defined storage challenges you can meet while building your infrastructure. This is all from me for now. I will next let our great speakers to do what they know best. Ken, can you please start?
Thank you, Mihaela. So just to perhaps introduce Sardina. So we are a cloud platform software company. We build a product called Sardina FishOS, building on the three key building blocks: OpenStack, Kubernetes, and Ceph. I'm sure some of you in the audience would know, there are quite a number of OpenStack-based players in this space. We tend to see ourselves being quite a differentiated player, focused on bringing innovation into the space. We have been around since 2014. The early days of the team came primarily from supercomputing, finance, defense, and telco. We're very much a European-focused player with our team today located in UK, Germany, Romania, Russia, and Ukraine. And on the partner front, we're very, very partner-friendly organization, as you see at the bottom right, our broad partner ecosystem. And we're very much honored and very much appreciative also that along the way, we've had the great fortune of winning a number of major industry awards. And one of the key innovation that we brought into the cloud platform space is our ability to upgrade systems in a reliable manner. And here, this is an acknowledgement from the OpenStack COO, Mark Collier, of our zero downtime upgrader. We're the first player in the space and still the only player that will provide assurance for zero downtime upgrade. And as well, you'll see throughout the presentation today, we'll talk a lot about how to ensure uptime, how to ensure reliability in a production cloud. Dominic, over to you.
Okay. Ken, should I switch to my file or we just use this file?
I'm flexible whichever way.
Yeah. Okay. So Hello, everyone. It's Dominic from Embedded Technology. So our company is fully focused on the software-defined storage solution, specifically on the Ceph solution. So the company has founded about 7 years ago in an incubation center inside the University of Taiwan. And the same year, we just launched the world's first ARM-based microserver platform. It's not only your ARM server, it's a microserver platform, which I will explain you later. And we deliver this microserver platform to our European customer for their cloud storage application. And since we have this innovative server platform 7 years ago, so we also have been invited to demonstrate this innovative product on the ARM partner meeting in the UK on the same year. And please, next page. Okay, so after we launched the hardware platform 2 years later, we just launched our first appliance product, which is our Ceph storage appliance with this ARM server to the world. And definitely it was a pioneer and the first product in the world as a Ceph appliance. So the same year, we just won one of the most important storage show, the Interop in the Las Vegas. It's the Best of Interop for the storage award. And also this product has won the Computex Space Choice Golden Award the year next. So about 3 years ago, the Ceph community have a Ceph foundation. So as we are fully dedicated and focused on the Ceph storage, so we became one of the founding general member for the Ceph Foundation as well. So from the 2016 to this year, we already have launched our third generation Ceph storage appliance platform to the market. And we still try to improve our product and service. Okay, this is our company. Ken, it's your turn.
So now when we look at planning a infrastructure as a service platform, invariably a number of questions arise. And these questions are typically around topics such as workload, what's capacity needed to meet the workload, how do we provision the system, how do we bring it up, how do we scale it up, and how do we then further orchestrate the system, and how to build it in a reliable manner. Now, if we delve into these questions a little more, in the interoperability area, invariably we meet this challenge, how to interoperate with multiple and varied hardware components, hardware and software components, and how do we run the system in a reliable manner. Reliability is key because this is how we're going to get and build and retain user trust. And as we scale, as we run the system, we're going to have to look at how do we scale it, and how do we increase the capacity to meet the workloads in a cost-optimal manner, in a flexible manner. And how do we ensure that the system continues to be up? How do we know that the system could be reliable to serve mission-critical workloads? And the flexibility aspect, in enterprises today, we encounter broad range of applications, and the platform certainly needs to be able to cater to these wide range of applications. And also, do we have the system architected, built in a manner that is defensive, so that we can prevent and manage security threats. And in today's world, we get into the data explosion era, as Dominic will take you further from here.
So everybody knows, like from now on to the next 5 years, for the expectation of the data storage, it will increase about 175 zettabyte within 5 years. And since all kind of data massively increasing today, how we could handle this massive data with the current storage. Next. So the first thing we need to know, the current solution, the legacy storage, it could not fulfill the future demand, since the first thing is very difficult to scale out and manage such a huge blooming growth. And also with all the proprietary storage or proprietary legacy storage, the IT expense will be pretty expensive if the data storage volume grows such extremely large. And the third constraint like we got with today's storage is today's storage devices it's difficult to fulfill or compatible to the future software-defined data center requirement. So how could we find the right data storage for the future demand? Next, Ken, please. Ken? Yeah, so to address all these constraints of today, the first thing we need to find a storage that it could be highly scalable and flexible for the storage capacity, also for the performance. And with all of this, the better is there is no single point of value in terms of the hardware. We know the current legacy storage, most of the data protection has been done with the controller, and the controller is truly a massive single point of value. And the second thing, if customer or enterprise, they could tolerate or they could take care for the current data storage devices, but with the growing capacity they need in the next few years, they also need to looking for cost efficiency product to adopt to more the data, incoming data. So reduce the IT costs become a very critical and sensitive topic for all the enterprise today. And also, since the technology is changing every day and the data capacity, the data store capacity increase with the time. So we need to find out the good solution to adopt the changing demand in terms of the performance, in terms of the capacity. And when we scale out the performance and the capacity or upgrade the software version, the end user, they need to have a good solution without any data disruption or the downtime for the production service. So which storage could be a good answer for that? We will introduce that later on for the Ceph storage. Ken, it's your part.
So perhaps I should also set the scene by addressing the two questions. What is OpenStack, and why particularly we're looking at FishOS OpenStack? So as for the question of what is OpenStack, it's in summary a collection of software parts that enable an operator to manage access to pool, storage, compute, and network. And in addition to programmable API, the system also comes with a web dashboard to give both the operator and the service consumer a way to interface with the system in a very comfortable manner. And in the infrastructure management space, today there is no doubt that OpenStack is the established, most mature solution for managing infrastructure. And it's backed by industry majors. And as a result, you also see it being the fastest growth infrastructure service platform today. If we look at FishOS, what do? We take the full distribution of OpenStack, we round it up with operations tools, with deployment tools, with upgrade tools to enable the system to be operated in a flexible, scalable, and efficient manner. Now, and so if we look at a system being brought up, the bringing up phase, the deployment phase, this should be quick. And so with FishOS, we provide a very simple, easy to get going deployer. And once the system's up and running, the focus turns to how to live with the system. And this should be the longest phase of the 3 phases of life cycle. And so how do we operate the system? Encompasses questions such as how do we manage logs? How do we handle monitoring? These functionalities, they come pre-integrated, works out of the box with FishOS. And when we talk about reliability, with FishOS, you get a highly available by default solution. This is built into the architecture. And I'll come to that later on. In a cloud, it's also very, very important to look at the matter of health, system health. Why? Because we are now having to ensure that the system is up and up and up at all times. But to enable that, to achieve that, we need more than traditional monitoring. Here, FishOS provides a machine learning driven solution that will preemptively detect potential failures, potential faults in the system to enable the operator to take preemptive action. And FishOS also comes with a workload manager that will automatically optimize the workloads within the environment, how to replace, how to rebalance the workloads so as to best match the workload to the hardware at any point in time. The net result for the operator is that you can then drop the TCO, dropping OpEx and CapEx. And with FishOS, as an organization, we are also very open to integrate with other players, working with partners. And today we have our partner Embedded in this session, precisely because we embrace partnerships with Ceph vendors, for example. And the solution has also been validated for the Open Compute platform. So as for the question of why storage, software-defined storage, why Ceph storage, Dominic will take you further.
Okay, I switched to my screen. So,
Okay.
So we just talked about the data storage challenge and how to address this difficulty. So it seems a software-defined storage could be the best answer. But among so many software-defined storage, what whatever is proprietary or is the open source. So embedded, today we have chosen Ceph storage as our solution to offer to the market. Why? So we have several reasons. As the first thing is, everybody knows Ceph is the most well-known and the most broadly adopted open source SDS in the market. And it also owns the biggest community for this demand in SDS. And compared to the legacy storage, the traditional ones, such like the IPsend or the NAS, Ceph, it could fix the performance bottleneck and provide a no single point of value problem for the storage solution. And not also mention Ceph, it provide a scalability both on the capacity increasing and also for the performance wise. So today, for the customer who is interesting for Ceph, they also looking for a one storage cluster with multiple storage protocol support. So Ceph, it could support block, file, and object. That means the enterprise or the data center, if they owns a cluster of the Ceph cluster, they could have multiple application and the use scenario based on it. Since we are here for the seminar with the OpenStack with Sardina system today, so I also want to mention Ceph is the most adopted cloud-native open source SDS. It's just behind the Amazon AWS, Google Cloud, and Azure. It's the ranking number 4 for the native support for the OpenStack and the Kubernetes. But the first 3, they are the it's the public cloud service. But for a lot of company, they don't want to embrace public cloud. They need to have their private cloud solution as well. So that's why Ceph is so welcome as well. So besides this intelligent storage software, it also provides a highly available design for the enterprise use. And for the block storage and the object storage, it also provides a very simple to use disaster recovery mechanism, which I could explain later on. So this is the reason we embrace Ceph storage as our major solution to the market. So on the next page, on the next slide, I will talk about embedded solution. I know some of you today might be your first time to know embedded product. So I will take about 2 minutes to quickly go through what we offer to the market for the Ceph storage. So today, our solution is a turnkey solution. Integrates 3 components. Is the ARM-based microserver, preload with the tuning Ceph, is the community version. As all of you know, like SUSE already abounding this market. So right now, to provide the community version will be the mainstream. And on top of the hardware platform and the tuning Ceph, we offer a Ceph management GUI, which we call it UVS Manager. The terms means Unified Virtual Store Management. So with all these 3 components, this turnkey solution lower the entry barrier for the end user or for the customer who want to adapt Ceph to their daily use, but who is not able to do today because it's open source, but it's not easy to operate for the engineer who don't know it or who is not experienced for that. So we try to lower down their entry barrier technically to allow more and more enterprise and the user could use Ceph storage. And the most interesting thing is it's a turnkey solution. So Embedded will be fully responsible and supportive for the software support to our customer. It's not only Ceph, since we also include the microserver inside this solution. So we will provide our customer the kernel level, operating system level, Ceph level, even the GUI management level to learn to fix their daily, their daily operation, the troubleshooting, and even for the upgrade service support. Everybody knows for the open source software, sometimes it has one version per year or two versions per year. So when the cluster need to be upgraded to have more interesting function, how to handle the upgrade procedure without any downtime or disruption on the service, that is pretty important for the customer. So we will help our customer for the upgrade service. Okay, so this is our product. So this product, it provides the multiple storage protocol usable for the end user. So the customer, either they want to use the native protocol on Ceph, the RBD, the S3 compatible or a Ceph file system, or they prefer to use their experience legacy storage, such like the iSCSI or the Samba or the NFS, is all usable and available with this turnkey solution. So on the beginning of this section, I mentioned we are providing a pioneer and a pretty innovative server platform to the storage market. So I will take this chance to explain you why it's so unique and the difference here. So you can see the picture is the top view of this ARM-based microserver. So as you can see on the orange block, every orange block lay out a microserver. It's an ARM server. The size is just smaller than your business card, but it's an independent Linux ARM server. It already fully integrates the processor, the memory, the onboard flash, and the true Ethernet. And we have 8 microservers inside one U chassis. And these 8 microservers, they cooperate with each other through the TCP/IP. So you could just imagine it's just like a private cloud inside this one U server. So why this is so interesting and unique for the Ceph storage? As most of you might know, Ceph is a fully distributed storage software. So to well adapt to the algorithm and the architecture software in Ceph, we design this fully decentralized microserver architecture. So that means every microserver to be defined as an independent Linux server, and they could define as the monitor node in Ceph, as a OSD node in Ceph, or metadata server node, or the gateway. You could define any role on this microserver node inside this one U chassis. And every microserver, they have their dedicated storage. This is pretty important as well. Because with the traditional server architecture, it always been one server motherboard handle many disks, or 2 server motherboard handle many disks. So if the user, they run the Ceph storage on the commodity server platform, it will encounter the problem probably if your motherboard or any component fail, then you lose many disks in one time. Of course, Ceph is an intelligent software, so it could do the Ceph recovery. We call it Ceph healing as well. But the more disk you lost in one time, the more data you need to do the recovery. And the recovery time will be longer. So compared to the general server you find in the market, with our microserver architecture, we could much shorten the recovery time compared to the others, and provide a much high availability Ceph storage solution to the users. So I will not go through all the detail about the Ceph functionality. If any one of you feel interested for that, welcome to contact us after this webinar. So just highlight some important and interesting function in Ceph. The first thing is fully distributed. So it could scale in or scale out as your actual requirement. So when you scale out the cluster will do the auto balance on the background as well. And the protection level and the risk level will be fully controlled on the software side. There is no controller, no physical or hardware controller in this cluster. The protection will be fully met, fully done by the algorithm with the quadrille. So you could diverse your risk to each disk or each chassis unit or each rack cabinet. If your cluster is bigger, it could be each data center or each region as well. And it could do the intelligent self-healing. So you don't need to be worried if you lost one unit or one disk during the 9 hour when there's no people or no employee to surveillance list. And we also provide the encryption level by the OSD disk. And the cluster provide the data compression. And for the disaster recovery, among two clusters, we could do the mirroring through our UVS manager. And the protection master, it has the replication of the data and also have the erasure coding. Erasure coding is similar to what you know with the RAID 5 or RAID 6, but it's more flexible. You could have elastic combination of your data chunk and the coding chunk to decide the storage efficiency and the performance. Okay, so I will take about 30 minutes to explain the disaster recovery because this is very welcome and useful for the enterprise who is fully focused on the data safety. So for the block storage level, the enterprise, they could have two Ceph cluster on different location, and we could use the asynchronous mirroring for the RBD, which is the block storage in Ceph. So every data change on the cluster A, it will be have the same data mirroring to the cluster B. So when the site A got damaged or crash, the customer, they just need to move the cloud host server point to the site B, then they could have the fully service back. And once the site A has been repaired or back to normal, then we could just fail back mirror to have all the current data, the most latest data back to the site A. All this procedure can be easily done through embedded UVS manager. As you can see the interface here. And also that's for the block storage. And how about for the object storage? The object storage for the customer who is interested on the Ceph with the object storage, usually they want to use Ceph to provide the S3 storage as their on-premise cloud. So for the DR consideration, they might have 2 cluster or 3 cluster, which could do the data backup to each other. So here we just demonstrate an example of the 2 cluster. If we use embedded UVS manager to define 2 cluster on two different location as the same zone group, then the data on the cluster 1, for example, the endpoint 1 to the cluster 1 and the endpoint 2 to the cluster 2. But every object, every data on the bucket in the cluster 1, it will have the active sync to the bucket in the cluster 2. So once you got one side fully destroyed or damaged, then you could just change your endpoint to the cluster 2 to make your service with no downtime. So these two are the disaster recovery function that Ceph storage could provide to the market, to the customer. Okay, Ken, it's your turn.
Okay, thank you, Dominic.
Yeah. You could share.
So,
yeah.
You're still reading my screen, yeah?
Yeah, this is my screen, so you could switch back to yours. So it's much easier for you to operate. Let me stop.
Let me come back to reshare the screen.
Since you have many pages, it will be easier for you.
Yeah. I'll reshare the screen and oops, my apologies. So as we look ahead, how do we build a infrastructure as a service platform? And how to, more importantly, how do we build a large scale platform? So there are a couple of things that a infrastructure service platform should not be. First off, it should not be a toy, and it should not be a consulting Trojan horse for your supplier, neither of which are in your interest. So if we look at the deploy phase, deployment of a cloud platform, this should be quick. Ideally, you want to get to the point where you can have the system deployed in hours rather than weeks and months. And if you have a vendor that can work with you to have the system deployed in factory, so that when it arrives at the data center, it's plug in power, plug in network, and off we go. That should be the optimal thing to do. Now, once we bring up the system, the first question in relation to efficiency, how do we make sure that the system resources are right matched to the workload at any point in time? And very importantly, the process of right matching workload to the system resources should be automated. There should not be any human sitting there pointing and clicking to move workloads around. While it may sound like a joke, we have actually come across such situations, and that's not too long in the past. And as I mentioned a moment ago, reliability and scalability is very important. So how do we enable a system that is highly reliable? First, we need a highly available architecture so that you get high availability by default. And secondly, we start to look at tooling, monitoring, and health management. They may sound very similar, but they're not the same. And on one hand, it is very easy to simply say, yep, you've got monitoring, checkbox ticked. But on the other, it's very important to look further and understand what exactly is being monitored. Where's the data coming from? What's the data? How's the data being collected? Where's the data going? And what can we do with the data? What decisions can we make with the data? How are we going to make a decision? And after we've made a decision, what can we do about it? And these are details in relation to monitoring. And in relation to health, what would be the goal is to actually understand that there is something that is imminently faulty within the system, where with a enterprise-wide cloud, enterprises today are increasingly facing developers that are that grew up in the Amazon era. So they expect the system to work and work and work and work at all times. So how are we going to do that? This is where health engine, health managers come in to play, to understand that there is imminent fault, to enable the operator to take preemptive action. And for the operator, it's important to have these tools all pre-integrated, as well as having the tools to actually understand what is being used. The usage accounting and billing systems, it should be there by default. And now you've built the system, run the system for 6 months, and you see the open source upstream coming out with a new release. Users love them. It's fantastic new capabilities, fantastic new innovation, but for the operator, this is a fantastically new headache, because now for the operator, you need to figure out how on earth you're going to upgrade the system. And these are the challenges that needs to be addressed within the system. So let's look at FishOS architecture. What we have done is that we've taken OpenStack, Kubernetes, and rounded up with a broad collection of tools in order to manage the system, in order to ensure uptime, continuous uptime within the environment. And the system is operated in a infrastructure as code model, using an Ansible-based tool, the FishOS deployer. So deployer is used continuously throughout the life cycle, not just at the point of deployment. Upgrader is also Ansible-based. And the system is also very simple in that all the components within it are packaged as traditional simple RPMs. So for an operator, all that is needed to get started is pretty much Linux experience. This enables the operator to bring on people without having to specifically recruit personnel who are familiarized with containers. So if we look at the solution architecture, we have the controller function, and we have the balancer function. For controller function, we're looking at least 3 nodes. This is to provide odd node based quorum. When the system is small, the balancers can be co-located on the controller nodes, but as the system grows, we would advocate that the customer separate out balancer function onto additional nodes. Balancer functions, they don't need to be high-powered nodes. Some customers run them on the highly cost-effective Xeon D nodes, which I believe are somewhere in the 1,000-odd euro mark. And system like this would also need compute. And so you add the number of compute nodes as necessary. And of course, that would be storage as well. So this is how we are able to segment out Ceph storage that you can also grow as necessary. And as you run the environment, you have more workloads there. You need more compute nodes. What do? Very simple. We add further compute nodes. You do not need to touch the controller nodes at all. And to add compute nodes, this is a simple process. You add the node into the deploy configuration, and you hit run. And so let me give you a number of example use cases. One use case here is machine learning. Here, the FishOS platform was used to provide a GPU accelerated machine learning environment. The users could self-provision both VM-based nodes with GPUs passed through into the VM, as well as multi-tenanted Kubernetes. So with the multi-tenanted Kubernetes in this environment, you also gain from strong segregation and high security assurance. And the users in this example case also have access to a common data set that's shared through a shared file system. A second example use case is also in the machine learning domain. Here, the customer has to deal with confidential data. So the storage volumes are encrypted, and like before, GPUs pass through into the VM through PCI pass-through. And we can also achieve optimality in the resource usage by moving VMs to those nodes when the GPUs are not being used. And then we move the VMs away when GPUs are needed. This can be automated. And the customer environment in this case, it incorporates a fully automated workload provisioning pipeline. So when the workloads arise, the VMs are created, the Kubernetes environments are self-provisioned, automatically provisioned through API, to run the computations. And in another space, in bioinformatics, in this day and age of global pandemic, bioinformatics is a hot topic indeed. And this customer has use case whereby users can bring their own data sets. So these are biological data sets that the service consumers can then use for computations, and they are able to launch workloads that use up to 3 terabytes of RAM and over 100 CPU cores. So see, it's very flexible environment to enable users to come and go to cater to their analysis pipelines. And of course, in these sorts of environments, you also have the microbial data analysis that is pre-packed in ready-to-use images for those purposes. And in another environment, this customer can go from data to their execution strategy, how they as a business are going to execute. It's a finance organization, so you probably have some idea what execution strategy could mean in this case. And here, a Git commit of the code then triggers the launch of a set of containers on Kubernetes clusters, and they are able to then very quickly interact with the system to do experiments, and they are also able to run the same system to then enable them to run certain execution strategies. And typical in this type of environment, it's very important to have network security, very strong network security that they then achieve by leveraging Open vSwitch in OpenStack. And now in another environment, in application hosting, web application hosting, the client has a set of curated applications that enable the service consumers to launch and are still able to customize post-launch. And they're able to offer customers with very flexible, self-managed environments that's able to scale to meet both the internal development as well as Black Friday type of workload spikes. Some of you may find it rather interesting also that the platform is also used to service one of service a customer, which is the hosting company's national orchestra. So if the system goes down, national orchestra goes down. Kind of amusing, isn't it? And with that, I'll pass you to Dominic to tell you more about Embedded Sardina cluster.
Okay,
Dominic?
Ken. Yeah. So everyone, since we are running out of time, but we still can continue if you stay with us. So just let me talk about the architecture on the embedded Ceph cluster. So we just review about how our microserver look like. So to bring up a Ceph cluster with embedded appliance, the first thing our customer need to know is how to configure for the network topology inside the unit, and also together with top of the rack switch. So by our default setting, we are using the trunk for the every microserver. As you can see, we have 8 microserver inside one U chassis, and every microserver we have two port of the Ethernet. So by our default setting, we just binding these 2 ports, and each port comes to one of the switch module inside our servers. As you can see here, wait. So we have 2 in-chassis switch here. So each microserver, we have 2 Ethernet. One connect to the in-chassis switch 1, one connect to the in-chassis switch 2. So on the first design, the default design is we bonding these 2 ports together to achieve a high availability for the network, which means even we lost one of the in-chassis switch, the unit is still on, but just with the reduced bandwidth. This is a pretty reliable method for our network configuration. However, for some customer, they might prefer to have the in-cluster, inside the Ceph cluster network and the public network separately. So we also offer the in-cluster and the public network separately. But in this case, one Ethernet on each microserver node will connect to, for example, to switch 1, and another to connect to the in-chassis switch 2. But if one of these in-chassis switch both lost, then the cluster will lose this unit. But the user doesn't need to be worried, because the Ceph still have the protection level in terms of the entire cluster. So this is 2 configuration for the network. And then, as we just mentioned, for different Ceph cluster could support multiple storage protocol with different scenario and the different application. So I will do a very short intro for how to deal with this. So for the user who want to use the Ceph with the object storage for the S3 compatible, the minimum cluster is three units. Then we could build up the Rados gateway externally, then to offer the object storage to the client. And this scenario frequently used for the private cloud on-premise, or for the OpenStack as the backend storage by using the Swift API. And for the block, for the native support RBD, the Ceph RBD, we still have 3 units as a basic configuration. For the RBD, it could have the direct mount to the Linux client. Either is the virtual machine or is the bare metal. So for the OpenStack or for the Kubernetes, or the customer, they are using the KVM or QEMU, all could support directly by using the Ceph RBD. And since this will provide the block storage for all these images, so customer, they could choose, if they are the performance oriented, they could use the SSD as the OSD disk in our storage devices. If the customer application is more capacity oriented. They could use the hard drive as the OSD disk. So it will be a question for choose the performance or choose the capacity. Or you could use the mix data pool inside one cluster is also working. Okay, so let's go next. So we talk about the object storage. We talk about the block storage. The Ceph cluster, our Ceph cluster also provide the file sharing system to the customer. So which we call it Ceph file system. Actually, Ceph file system is a POSIX compliant file system on top of Ceph. So for the backup software such like Vim or Convo, it could work directly with the Ceph file system for their repository. And also for the OpenStack, Kubernetes, or Nextcloud, this kind of the infrastructure, they could also working directly with the Ceph file system. So in this case, the end user, they could consider it's a scale out larger the file sharing system. Okay. So for the first three, they are the native support storage protocol. But for a lot of the user today, they are still used to use the iSCSI, NFS, or Samba. So how to deal with this? So for the customer who still prefer to use the legacy storage, we also have the solution. For example, for the iSCSI, we could convert the Ceph RBD to the iSCSI by providing the iSCSI gateway in between. And this iSCSI gateway, it could be scaled out as well. So it could be one gateway or two or three, depending on the performance like your application require. And in this use scenario, we also support the multi-pace I/O and the IQ and access control, all the necessary things on the iSCSI. And for the client side, it will be used with the VMware or the Windows. Today, for the VMware, they don't support the native protocol with Ceph. So the only durable way is through the iSCSI. Okay. And the next one, to provide an NFS service or a Samba service is the same logic as iSCSI, but just differently, we convert the Ceph file system through the gateway to provide the NFS service and the Samba service. Then we strongly recommend our customer to have the external gateway. This gateway could be a physical server. It could be a virtual machine as well. And not locate this gateway inside our Ceph appliance, since each microserver, the bandwidth of each microserver is about 2.5 gigabits per second. So compared to the external one, the bandwidth might be limited as a gateway role. Okay, so let's all come with different using scenario. We have different architecture to our customer. So with the next slide, I will talk about some use case we have done with our customer. So the first thing is our customer use our Ceph storage as the backend storage for their OpenStack infrastructure. And the most of the case, the customer, they are using the RBD. Actually, today, when customer, they are using the OpenStack, about maybe 80 or 90%, they are using the RBD. Very few of it, they are using the Swift. It's very, very seldom. Okay. And this example is one of the medical application, the customer application, they offer the data analytic for the radiology data for the patient safety. So they have the data to be shared among their team. They want to use two protocols, the Ceph file system and the S3. As we know, for the S3, for the object, usually the user, they are not so performance demanding. So on this use case, customer, they have a hybrid design. So they are using both hard drive and the SSD for the OSD disk. So they are using the S3 with the hard drive pool, and they are using the Ceph file system with the SSD pool. And they could have this scalable, flexible, and the mixed pool Ceph cluster just with 3 units of our solution. So it's very easy for their future expansion, and also they could have different performance for their data pool. Okay, and this example is for the IPTV platform. A customer previously they are using very expensive scale out NAS devices for their service. For their OTT and the IPTV platform, they are using the EMC Isilon series. But since they anticipate the performance and the capacity requirement in the very near future will grow up very quickly, so they want to switch from the proprietary scale-out NAS Isilon series to the Ceph storage. So they are using our Ceph appliance to provide 2 protocols. Majorly is with the S3. The S3 will be supported to their OTT and the IPTV service to the end user. And at the same time, since they have some middleware system file need to be stored in this cluster. So they are also using the Ceph file system in this cluster. So it's also a mixed design for this customer. Okay. And this example, it includes several customer use scenario. It's use Ceph cluster for the massive data backup. So if you ever hear about what SUSE promote in the market for the SUSE enterprise storage or Ceph storage, I think you must already know Ceph is very suitable for the archive and the backup application. So either today customer, they are using their proprietary software for the backup, or they are using a Veritas or a Convo or a Vim, they could have the data backup to the Ceph cluster, and all the protocol is supported. It could support it by a block RBD or a Ceph file system or object. However, if they are using Ceph file system, this is most easier to use because for the shared file system, it's very easy to be resized. If they are using the block RBD, then every time when they want to resize the data pool, this could not to be done resized in line. So for our customer, if they check with our opinions, we always recommend it to use the Ceph file system. And the last one is they could also put the backup data to the S3 object storage, but this has been most used as a cloud tiering. I will expand on this slide. So we know, for example, EMC, they have a very expensive backup series to be work with their data domain series. So the data domain is it's just like a backup server to adapt all the data source, like the virtual machine. It could have the email database or the application. And the list devices is pretty expensive. And when this data domain has occupied all the available usable capacity, they have a secondary device which called the ECS, Elastic Cloud Storage Series, to adapt the data from the data domain. So with the Ceph storage, with the embedded Ceph solution, we could replace the role of the EMC ECS series. So we could work with the EMC data domain to accept or to store the data out of the capacity here. And if customer, they want to do the disaster recovery for these data, they could also deploy another Ceph cluster in any location. Then we could do the multi-site active support for their data. For this scenario, we could help the customer. They are not limited to use the same series of the EMC model to achieve a most cost efficiency, but have the same function and more flexible storage capacity for their cloud tiering. So this is for the backup as well. And the last thing I want to mention is use the Ceph storage for your edge data center or edge application. Since I mentioned, I already showed you the picture of our Ceph appliance. You must notice like it's very small one. It's not a huge machine. It's just a 1U server, and it's based on the ARM, so it's very low power demanding as well. So some of our customers, they are using this advantage to put 2 or 3 our Ceph appliance inside a small rack as their edge data center storage usage. So the maintenance is quite easy because with all the intelligent storage function, they don't need the operator to put such effort to take care of it. And also the power consumption is such small compared to the commodity server you could find in the market. And the capacity could be scaled out. So they could starting with 2 units or 3 units in the beginning. If they have more data to ingest or to store inside this cluster, they could scale out in the future by their actual demand. So for the industry who have many small edge data center, either to collect the IoT sensor data or to, our customer, they are doing the gas and the natural gas and the gasoline petrol business. So they have so many small rack and the edge data center. So this is quite convenient for them. So this is some of the use case that we have done together with our customer. And the next Ken will talk about us. Okay, you already listened what FishOS could offer you in terms of the OpenStack infrastructure, and also the Ceph storage could offer you a scalable, reliable, and the elastic storage. So what's the joint benefit if work with Sardina system and the embedded technology? What we could bring you for the benefit? Ken, do you want to share?
Sure. So let's keep this slide here so that we don't spend any time switching. Yeah. One of the key benefits with a joint embedded and Sardina solution is that you are able to gain the best of both worlds with the operations tools from Sardina and the Ceph storage solution from Embedded. So as an example, we connect the logs and metrics from storage system into the health manager in FishOS. This enables the operator to then effectively get to see the full system in a combined view, gain greater flexibility, and you improve the visibility into the environment, understand what's going on, understand what could be going wrong, leveraging our health engine as well. And ultimately, the aim is to achieve zero downtime operations. I hope this gives everybody in the audience a quick view on the joint solution, the benefits that you gain. Next slide, Dominic.
Oh, yes.
Where to find us, how to buy a joint solution. From Sardina side, we have a broad worldwide network that can provide a solution. Come talk to us. We don't bite, I guarantee you.
Yeah, you don't bite. Okay. As for Embedded, we have our regional partner in Germany, UK, Turkey, Korea, Thailand, and Indonesia. So if you have any question or you need any local support, welcome to address to our partner. After this webinar, you will have this presentation file, or you could visit our website. You could find the contact information with our partner as well. So I think that's the entire content we want to share with all of you today. So the next will be the question about this webinar.
Great. So thank you very much, Dominic. Thank you, Ken, for presenting. We are now continuing with the Q&A session. And we have received some questions on our Facebook Live page. We are live on Facebook. And also we have one question here from one participant. And I do encourage you to write us more questions if you have. So I will start with a question from that we have here from Benny. So the question is, regarding the multi-tenant Kubernetes, is each customer a shared master node or is it dedicated master node per customer? Ken, I guess this question is for you.
Sure. So yeah, it's dedicated for each of the customers. So this is true separation for the service consumers.
Great. Thank you. We have another question from Facebook. What are the system specifications to start with for OpenStack? How about software-defined storage? And how big can the system become? So I guess, Ken, you can start, and then we also have Dominic to answer.
Sure. So I'll address the controller nodes and the controller, compute, and balancer function, and Dominic can handle the storage part. The controller nodes, we recommend at least 96 gigs of RAM and 20 cores using, for example, the Xeon 4114 processors, which today are already several years old. Those would be a baseline, so to speak. And you be looking at 3 nodes of those. And the balancer function, as I mentioned, little earlier, you can very easily use the Xeon D nodes, very lightweight and very cost effective as well. And from there on, you can add however many compute nodes as necessary, really, to fit with the workload that you intend to run on the system.
And for the Ceph storage, as I mentioned, we are a turnkey solution. So the customer who choose embedded Ceph solution, they don't need to worry for the platform because we already have the dedicated server to come together with. It's an on server. And to achieve the high availability for the Ceph storage, we recommend the user to start with at least 3 units of our MAS 400 series. Is the server that we show you during the section. And a Ceph is all the communication will be done with the TCP/IP. So our user also need to have the turnkey switch as the top of the rack switch. All the Ceph appliance will connect to this turnkey switch for the communication, either for the public cluster and for the public cluster. Yes. So hope it's clear.
Okay, thank you. We'll continue with another question from our audience, from Jem. So they use Miles 1 system video management software. Do you have any idea about video management software solution with FishOS and Ceph side?
I'll try to answer the FishOS part. So with with video management, with FishOS, you could take a agnostic view, such that the infrastructure side of things, so long as resources are well provisioned for the workload, you can be agnostic as to what's the actual workload. And so my understanding of the video management systems, typically there is substantial network and storage I/O. And so the system should be well architected to enable these sorts of workload patterns. And if there is video processing happening in the software, we should also take that into account. And for example, if there is GPU acceleration necessary.
Okay, so let me explain on my part. I think Ethan, you want to write milestone, right? It's a typo error, miles 1, but you want to talk about the VMS of milestone. Actually, we could, for the Ceph storage, it could connect to no matter which VMS that you are using. But today, embedded, we have cooperated with one company which called Network Optics. I already put the link to all of you. So you could check this link and to see how we could do the cooperation with Network Optics. So I do short explain here. Actually, we could integrate this VMS software and the Ceph storage all on the same micro server. So you could run the NX server from Network Optics on our MAS 400 and also to connect to the Ceph storage in the same devices. So this is the privilege of our microserver architecture since we have so many small nodes inside the unit. Okay.
Good, thank you. Another question from Omer. What is the embedded hardware warranty period? 3 years, 5 years? And do you have Mtbf test results?
Okay, so our warranty period, the standard one is 3 years, and we could have the extended warranty to offer to our customer up to 5 years. And for the Mtbf, we have the simulation on the on microserver. I don't have the accurate number, but as I remember, it's about 120,000 hours. It's about 7 years. If we calculate to the years, it's about 7 to 8 years, I remember. Yeah, but we could send you the accurate number after the webinar. This is the number on my mind, but it should be roughly accurate.
Thank you. One more question. I guess this will be for you, Ken. How is our OpenStack solution compared to another OpenStack solutions based on container, like Cola Ansible? Are you still, will you be changed in the future? I know Sardina OpenStack is RPM based.
Yeah, so today we are RPM based, and I would say we do not have any plans in the near future to switch away from RPM based, simply because with RPMs, this is very, very, very mature technology, and we have over time evaluated, re-evaluated, and re-evaluated multiple times solutions like and architectures like Cola Ansible, and we couldn't see a situation where Cola Ansible would have an advantage, and the functionalities that you can achieve, or rather that is intended to be achieved with something like Cola Ansible, you can achieve that much, much more simply with a RPM-based solution in FishOS.
Thank you. One more question from Facebook. It's for Dominic. It's regarding storage. What kind of technical support do you offer with your Ceph storage appliance, Dominic?
You mean what kind of technical support, right?
Yes, yes, the technical support.
Okay, since we are a turnkey solution, so our technical support including, okay, let me say on this way, Ceph community roughly have 2 versions launch every year. So our roadmap of our software offering is aligned with the Ceph community. So usually when the community have their mature version release, we will have the appliance, I mean the compact software to launch about maybe 4 months later, 4 to 5 months later. Then with the new version launch, we might tune the operating system, the kernel level, and also integrate the latest Ceph and the modification on our GUI management, since sometimes new Ceph version will come with the new functionality. So we will modify our GUI management as well. And all this included on our technical support. We will offer the upgrade firmware to our customer, and our technical support, it could be the consultancy of the Ceph storage. It could be the remote access to help them to fix the problem, or to help them to deploy the cluster. So all this could be requested by the customer.
Great.
Is that clear?
Yes. Yeah. Thank you. So there are no more questions for now, but I do encourage you to contact us and send us all your questions by email. I would like to say a big thank you to our speakers, to Ken, thank you to Dominic, and thank you to all of you who stayed with us more than estimated, who stayed with us 1 hour and a half.
Yes.
As a next step, we will be sending you the webinar recording and the presentation slides. And as mentioned, if you have questions, please drop us directly by email.
Okay, thank you, everyone. Thanks for your participation. Bye-bye.
Thank you.
Thank you.
Thanks, everyone. Bye.
Bye-bye.
Bye.
Hela, anybody else on?
Yes, they are still on.